Hey guys, welcome to our final question from the Pure Maths 1 test from term 1, and we have this function here on screen, f of x is equal to p sine squared 2x plus q, and the first part of the question is we have to state the range of f. Okay, so the range is from this bottom point here up to this top point here. That's our range. Let's see if we can figure this one out. Okay, I want you to imagine when we were doing sine 2x, what is the lowest range we have in a sine graph? Well, if you consider your sine graph, a typical sine graph, even sine 2x is just going to go up to positive 1 and down to minus 1. But when you square 1, that becomes 1. When you square minus 1, that becomes 1. So the lowest value we can have in sine squared x is 0. 0 squared is 0. And 0 times p will be 0. So the lowest point we can have, therefore, is when we have the sine squared 2x equaling 0. That will mean whatever p is, if we times it by 0, that's 0. So these bottom values here are all going to be q. So that's q. Okay. Well, what's the highest value we can get? If sine squared 2x, the highest we can get from the sine squared 2x bit is going to be 1, and then therefore the highest we can get is going to be p times 1 plus q. So these top points here are going to be p plus q. And therefore, when we pop this into how we define our range, we would say that q is less than or equal to fx, or f of x, and in addition, the second part would be is less than or equal to p plus q. So that's the first part of the question. Let's move on. We have to now state the number of solutions to the following equations. F of x, the first one is f of x is equal to p plus q. Okay, where on this graph do we find p plus q? We find it here and here. So there will be 2 solutions. Okay. So our next one is where f of x is equal to q. Well, we've already seen this. These are our low points, our troughs, and we've got 3 points where f of x equals q. The final part to part 2 is where is f of x equal to 1/2 p plus q. Now we know that the top of our graph, these 2 points here, that is going to be p plus q. So half p plus q must be somewhere in between. It's going to be greater than q and less than p plus q. So it's going to be in here somewhere, and you can see in that case that we're going to have 4 solutions. So that one will be 4. So we've got 2, 3, and 4. This brings us to the final part of the question, where we have to solve an equation for the case where p is equal to 2 and q is equal to 2. Sorry, p is equal to 3 and q is equal to 2. So let's just do that now. We'll clear this whole page and we'll write our equation. Okay. Here we go. Let's have a go at this. Okay, so we're going to have 3 sine squared 2x plus 2 equals 4. Then we are going to pull this across to here, so that'll make it 2 on that side. Then we're going to divide everything by 3. So we'll get in our second line, I've skipped a bit, but I'm sure you geniuses will be with me on this, is equal to 2/3. Okay, now we need to take the square root of both sides, so we'll be left with sine 2x is equal to plus or minus the square root of 2/3. Okay, hopefully that's making sense to you so far. Now, what we need to do now is use our calculator to find out those values. So, turn the calculator to radians. I'm going to do the positive square root first of square root 2/3. So 2x is equal to 0.955. That's to 3 significant figures. Now, we need to, we are working on this equation and we've been given, we're looking at between 0 and pi. Okay, so I've just noticed an error in the test. We're going to do ours for between 0 and pi. Now, if it's a sine graph, normally pi would be here, so this would be pi, and this would be 2 pi over here. We're only going to pi, but since we are finding values of 2x and we've set our range, even though our range is dodgy in the actual question, we've set our range to 0 is less than x is less than pi. That's what I'm going to set the range to. But since we're getting 2x, we need to extend our range to 2 pi, as we discussed in class. Alright, so if we've got one at 0.955, and here's pi over 2, or 90, we must have another result here. And we can get that other result by typing into our calculator pi, subtract 0.955, and we should get 2.186. So 2.186. Okay, I hope you're happy with that. Now, the next step is to use our calculator to find our negative square root. So inverse sine of the negative square root of 2/3. And for this one, I'm getting negative 0.955. So I'm just going to extend my graph a little bit, and that's over here. And you can see that there will be 2 values in the range, one here and one here. Now, to get the one that I'm putting a red circle around, this one here, we're just going to simply add 2 pi to negative 0.955. So if I add 2 pi to that, I'm going to get 5.3. So 5.328. Now, to get the final one, I'm just going to add 0.955 to pi. So that will give me 4.096. And at this point, we can ignore that value because it's a negative value, it's not in our range. But we're just going to divide all of those other 4 by 2 to get our final answers for x, because they are all given as 2x and we need to find x. So the first one is x is 0.478. I did that by dividing 0.955 by 2. Now I'm going to divide 2.186 by 2. That will give me 1.09. Divide 4.096 by 2 gives me roughly 2.05. And finally, dividing 5.328 by 2 gives me 2.66. Well, I really hope that helped you understand how to solve this question. I imagine some of you found it a little tricky, but keep practicing, because practice will help you improve, and keep asking your questions.